Hi, this is Chris Schomburg, and we're going to talk a little bit about two's complement arithmetic and adding and subtracting. So really, when you add a two's complement number, you just add like a regular binary addition. Now the key thing here is subtraction is really just what you do is you convert that binary number into a negative two's complement and then add. So in a sense, you're just adding again, you're not really subtracting. So that's kind of the key point. So regular binary addition, and then when you do that, when you add in binary using two's complement addition, you ignore the most significant bit if it goes beyond the 8-bit level that we're looking at. Okay? So let's look at this example in two's complement, and then we'll actually work an example as well. So let's just look at this example to start out with. We see here we have our true binary for 35. So 35 is our number. We have true binary for that, and that is going to be 32 plus 3 is 35. So that is our true binary. Now our two's complement is going to be the identical thing because we have a positive sign here. Okay, so because it's positive, 35 in true binary is the same as two's complement. Okay, now if we were to do negative 35, we look at the two's complement, which is the same as the 35 before, and then we complement it. We do a one's complement, which means that anytime there's a 0, there's a 1, a 0, there's a 1, there's a 0, a 0, there's a 1, a 0, there's a 1, a 0, there's a 1, a 1, there's a 0, and a 1, there's a 0. So then essentially what we do is we have a complemented number here. Then we add 1 to that, and then that is our two's complement number. And it's really not easy to see, but really from this point it's really not easy to see that it's 35, but we can tell that there's a 1 in front, so we know it's a negative value. To convert it back, it's really you just have to do the same steps that you did. So let's go ahead and look at this one. So if we were wanting to convert it back, we'd make this a 0, we'd make this a 0, this a 1, this a 0, then 0, 0, 1, 0. Okay? And guess what? That gets us back to our 35. Okay? So see this right here is the 32. This right here, oh, we still have to add 1. So we add 1 right here. And let me erase that real quick here. Okay, so we still have to add 1 just like we did before. And we get 0, 0, 1, 0, 0, 0, 1, 1. Okay, and now this is our 35. If you want me to prove it, I have, this is the 32-bit. This right here is the 2-bit. And okay. It's going too fast for my computer. That's the 2-bit, that's the 1-bit. When we add 32 plus 3, we get 35. We should get 35. Okay. Now we have to note that we noted that this right here is a 1, so that must mean that we have a negative 35 here. And that's actually our answer. Okay. 60. Okay, so what we're going to look at is we're actually looking at converting negative 98 to decimal in decimal to a two's complement number. So the first thing that we're going to do is we're going to confirm that this is 98. So what we're going to do to do that is we know that this right here is 64. This is 32, so we add those together. And then we add 2 to that. This is the 2's place. So what we have is we have 64 plus 32 plus 2 is going to equal, well, 32 plus 2 is equal to 34 plus 64, which is 98. That's 98. Because we get 4 plus 4 is equal to 8. So that's 98. So that is our solution there. So that is correct. So now what we need to do is we need to do a 1 complement of the whole thing. So that anywhere there's a 0, there's a 1 there's a 0, 1 there's a 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1. Then we add 1 and we get 0 plus, or 0, 1, 1, 1, 1, 0, 0, 1. So that's our 2's complement number, and we have a 1 in front of it, so it's negative. So we wanted to convert it back just to check to make sure that it's correct. What we could do is we could do a complement of the whole thing. Okay, we do a complement of the whole thing, and then we add 1 to it. Okay, and that looks identical. It's identical right here to here. Those are both identical. So that's 98. We want a negative. We put a negative sign in front of this because we had a 1 here. Okay, so that's how we know it's negative 98. Okay, so we can do a couple more examples of this. So if we have 2's complement, or if we have basically converted 1, 0, 1, 1, 0, 0, 1, 0 into 2's complement to decimal, we can just do it real quickly. So what we have is we have the 2's complement is right here. We know it's negative because we have a 1 in front here. This is a 1 here. So that 1 means that it's negative. So the first thing we're going to do is we're going to add 1 to it. When we add 1, this becomes a carry. We get 0, 1, 1, 1, 0, 0, 1. Okay, now we just check to see what's in there. So we have a 1, we have a 2, we have a 4, we have an 8, 16, 32, 64 is what we have. So if we add them all up, we're not going to have a 1 because this is a 0 right here. So this is 0. So don't add that term. So it should be 64 plus 8 plus 4 plus 2. And so when we get that, we get 78. And it's a negative sign because we had a 1 right here. A 1 right there means that it's negative. Okay. So we're going to work a couple more examples of 2's complement. So here what we have is we have 18 minus 7. We know in our math that 18 minus 7 is going to be 11. Okay? But what we can do is we need to actually do this. So to make a negative number of a 2's complement, we really have to do the 1's complement, add 1, and then we should be good. So here we go. We have 7 right here. And 7 this is our true binary. Okay? And so we know this is 7 because this is 1 plus 2 plus 4. So 4 plus 2 is 6 plus 1 is 7. Then what we're going to do is to make a negative 1, we do 1's complement. So anywhere there's a 0, there's a 1. 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. And anywhere there's a 1, there's a 0. So we just kind of make a complement of that. Then we add 1. Okay, so then adding 1, we get this value right here. And this right here is our negative 7. Okay? So now we have to put in 18. So 18 is going to be 16 plus 2 is 18. So we have 18 right there. And then we're going to add our negative 7. So when we do that, we get a 1 that drops down. So we draw a line right here. The 1 that drops down, we get another 1 that drops down. We get a 0 that drops down. We get a 1 that drops down. We get a 0 and a carry. We get a 1 and a 1 plus 1 is 0 and a carry. We get a 1 plus 1 is 0 and a carry. And so then we get really a 0 and a carry outside of our domain. So we ignore this 1, the most significant digit of 1, because it's outside of the domain that we're going to be working with. So in this case, what we have is we have just between here and here, so 4 digits. So actually, yeah, that's actually good. That last 0 is fine. So all we're working with is 8-bit binary. So the 1 right here we ignore, and so what we're left with is 8 plus 2, which is 10, plus 1 is 11. So that's 11 in decimal. And so we're left with 11, and so we have confirmed that 8 minus 7 is equal to 11 in 2's complementary numbers as well. Okay, so let's look at another one. So we have, this one is 66 minus 14. We know that's 52, okay? So we know that this is 52 if we subtract it. But let's actually work it out. So the first thing we're going to do is we're going to change our 14 into a negative number because we want it to be negative 14. So we have our 14 right here. So this is 16. So this is 8 plus 4 is 12 plus 2 is 14. Sorry, 12 plus 2 is 14. So that's 14 right there. So then what we're going to do is we're going to do a ones complement. This is a ones complement. Okay, so what we're going to do is we have a 0, we have 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. Okay, so that's all correct. Then we're adding 1 to it, so this is our process. So we add 1 to it, and we should get a 0 here. We're ignoring above this line because that's just 14. We're doing 14, negative 14 plus 1, so we have 0 and then a carry. We have 1 here from the carry. We have a 0, 0. We have 1, 1, 1, 1. Okay, so this right here is our negative 14. Okay, so now we're adding, so basically we're doing 66 plus negative 14, and this is our negative 14. So what we do here is we go ahead and we add them, and we get a 0 right here. We get a 0 carry the 1 right here, a 1 here, a 0. Then we get a 1 plus 0, we get a 1. 0 plus 1, we get a 1. We get 1 plus 1 is a carry. So we get a 0, carry the 1. 1 plus, so we get a carry here. 1 plus 1 is a 0 and a carry. And so that is our carry. Now we ignore the most significant bit because again we're only wanting 8-bit binary. Okay? So this is 1, 2, 3, 4, 1, 2, 3, 4, that's 8 bits. Okay? So then this is our solution right here. So we have to then check it. So then the next thing we're going to do is we're going to say, well, this is actually, okay, so well, this one is actually 1. We don't have it. This is 2. This is 4. So we do have 4. So we actually have 4 in this line. Okay, then this would be 8, this would be 16, this would be 32. Okay, so what we have is we have 32. Okay, so what we have is we have 32 plus 16 and then plus 4. Okay, so 4 plus 16 is 20. That's 20 plus 32, that's equal to 52. And we have confirmed right there that our binary number right here is equivalent to our decimal number, okay, with 2's complement addition. Okay, now we're going to go ahead and switch, and we're going to talk a little bit more about BCD numbers. Okay, so there's really, before we do too many problems, I want to actually look at adding BCD numbers. So what we have with BCD arithmetic is you're going to group binary groups or digits into combinations into 4-bit binary combinations for 10 decimal digits. So what we're going to do is what we're going to have is a range of numbers between 0 and 9. If we have anything really greater than 9, we're going to have to do some special rules. So really, when you do addition of BCD numbers, you can add as regular binary numbers. If the sum is greater than 9, or if it has a carryout is generated, it can't do it. So what we have to do is you have to add 6 to save the carryout. And so adding 6 will actually generate that solution. So BCD numbers. Why are we learning this? Why would we want to know how to do this? One thing is, when you use a 7-segment display, which I'm going to teach middle school youth how to use it, but when you use a 7-segment display, really, if you think about it, you could only have numbers between 0 and 9. Okay? And why is that? Well, if you do 10, you're going to have another 7-segment display. Okay? So essentially, you'd actually have to have, so this digit could be, if I wanted to do 10, I'd do that, and then I'd have to do a 1. Okay? And so that's actually how I could create a 1 and a 0 here. So I'd have to have 2 of these. So I'd have to carry over to the next one. So a rule to do this, the rule that we have is when you have something greater x is greater than 9, you have to add 6. Okay? And we're not really talking about 6 that way, we're talking about the binary 6. Okay? So let's go ahead and maybe this will be more clear once we've worked with a couple of problems, and hopefully that will kind of clear it up, and you'll see kind of what we're doing. So we have 29 plus 81. Now in decimal we know that is 0 because it's 10. 9 plus 1 is 10, so we get a 1. And then we get, this would be 10, 10. So it's going to be 110, 110 essentially. So we get a 8 plus 2 is 10 plus 1, so we get 11 there basically. So the 1 comes down and we get a 10. So we get 110 right there, and that is the solution. Okay, but what we're going to do is we're going to work out a binary number now. Okay, so that's our first code, so that's our decimal addition. So what we do is if we do BCD numbers, it's actually pretty easy to write BCD numbers because they're really pretty simple. Okay, that's 2. We can see that that's 2 because this is the 0, this is the 1 digit, that's the 2 digit, that's 2 for this digit of 10. So for that 10's digit, we have 2. Okay, and then we have for the 1's digit, we're going to have 9. So really, what we're going to do is we're going to go 0, 0, 0, 1, and that's 9 because that's 8 plus 1 is 9. So that's in B, C, D. Okay, and then the other one's pretty easy to write too because we have 81. So really, that's just this. Okay, that's 8 right there, and then we're going to get 1. That looks right. Okay, so we add them. When we add them, we just add them like normal numbers, binary numbers that is. So we have 1 plus 1, we're going to get a 0. We're going to get a carry 1 right there. And we're going to get a 0, and we're going to get a 1 right there. Alright. What's wrong with this number? This number is actually above our range, okay? Because if it's greater than 9, we have to actually add 6 to it. So we're going to do that in a little bit. First we're going to add this next part. So we get 0 plus 0, 1, 0, 1. Okay, that's the same thing. So we have both those two digits are the same. So what we're going to have to do, okay, I'm going to switch to another color. Both of these, we call this invalid. And we call this invalid BCD greater than 9. Okay, so we have an invalid BCD number greater than 9. Both of these are that way. So it's that one and that one. Okay, so what we're going to have to do is we're going to have to do this rule where we add 6. Okay, so we're going to add 6 to both of these. Now, depending how you look at this, it's easy. I think it's easier to do it one at a time. Okay, so let's actually add this one at a time, and because I don't want to get too ahead of myself. So here we have a 0. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. So we get a 1 here. Okay? So there we go. Now we're not done here. This is still BCD number, but we need to add 6 to this column because it's above 9. Okay? So we go 6 is actually, I did that wrong. Okay, so 6 is 0, 1, 1, 0. Okay, so when we add this, we get a 1, 0, carry 1, 0, carry 1, 0, carry 1. Okay, and then we just add our zeros here. There we go. And that is our final solution here. This is a BCD solution. So what we should do is we should actually write it in BCD form. So I'm going to go ahead and erase this 1 here. I'm going to move it up a little further. There we go. So this one right here is a 1. This is a 1, and this is a 0. And that is in decimal. This is in BCD form. This is in decimal. This is in decimal right here. Okay. So that is our first one. So that's the first one on how we actually solved. Okay, and you can see that each of these segments right here could be, so if we were to actually draw this, we could actually we would need another 7-segment display. Okay, so we would need, so this would be a 0, this would be a 1, and this would, didn't change the color. This would be a 1. So essentially what we would have, draw it in another color. This is a 0, a 1, and a 1. And that would be represent our decimal number using a 7-segment display. And we usually program 7-segment displays with using converting from a BCD number. Okay? So we're going to go ahead. We're going to close that. Okay. So let's do another one. Okay, so let's go ahead. Okay, so let's go ahead and do the next one, which is 190 minus 17, or plus 17. 190 plus 17. So when we add that, we're going to get 207. Okay, so if we do this, our binary numbers are going to be 0, 0, 0, 1, 0, 1, 0, 0, 1, and then 0, 0, 0, 0. 17 is going to be 7, and then in binary BCD numbers, this is a 1, and then this is going to be all 0. Okay, so it's a little bit different in BCD than it is in just regular true bit binary. And why that is because in true bit binary, this would be the 16 digit. So we're doing 1 for each of these decimal points here, or each of these places, these 10 digit, this is the ones place, the 10th digit here. So the ones place right here is 7. The tens is 1. And the hundreds is 0. Here we have the ones is 0, the tens is 9, and the hundreds is 1. So that's really why we do that. So when we add these together, we're just going to add them just like regular addition. So we get 1, 1, 1, 0. Then we get 0, carry 1, 0, 1, 1, 0, 0, 0. Okay, and I lost kind of my break though, so let me do that again so that we can see that we can have a breaking point between the two. There we go. Now, the key thing here is we have to add 6 because this breaks our rule. We didn't carry over to the next level on any of these, so we don't have to worry about carry. And this is just 1, and this is 7, so it's below our 9 limit. So we're just adding 6 to this center one. Okay, so when we add this, we get 1, 1, 1, 0. We get 0, 0, carry the 1, 0, carry the 1, 0, we carry it up to hit this one, we get 0, carry the 1. Okay, so now when we read this, this is 2 in the hundreds digit, this is 0 in the tens digit, and this is 7 in the ones digit. Okay, so that is actually the correct solution. Okay. Alright. So let's look at the next one. So we have, I just made this problem up. This is not in your book. Okay, so we have 154 plus 157. When we add these together, we're going to get 7 plus 4 is 11. 5 plus 5 is 10, so that's 11. We get 311. Okay, so that's our decimal value. Now to create this, we're gonna go 1, 2, 3, 1. So there's 1 in the hundreds place. We have 5 in the tens place, and we have 4 in the ones place. So that's 1, 2, 4. Okay. 157 has 100, or a 1 in the hundreds place. So it has 5 in the tens place, and it has 7 in the ones place. Okay, and we just add these together with normal arithmetic. Okay, we didn't have any carries in this case, but we do have invalid values greater than, so what we should do is we should write these out. So we should say we have an invalid BCD number because it's greater than 9. So we have it there and we have it here. So we need to add 6 to those. Now in this case, I'm going to do it in one stroke. Okay. So we're going to do it just in one step. I encourage you, when you work, to take your time and don't do it all in one step. In this case, I'm going to do it anyways. Okay. There we go. So what we have then is we should have a 3. This is 1 plus 2 is 3. We should have a 1 and a 1. And that is correct. So that is 311. And this is our BCD number. Okay. So we're going to do another one that's a little bit more challenging. And I want to present it because I think it's an important one to do. So we have 78 plus 69. Okay, so 78 plus 69, well, 8 plus 8 is equal to 16, so we have 17. We get a 1 here. 7 plus 7 is 14, so we get a 147 is what we get for this one. Okay, so we'll look at this in a little bit. So we're going to need to use BCD numbers, so this is our decimal number. We're going to go ahead and change it to BCD. So we're only going to have 2 columns here, or 2 groups of 4, because we have 78 and 69 are just the ones place and tens place. That's all that we have in each of those. So we're going to have 8-bit binary to start with, and then we might extend out as we go. Okay, so here what we have. We have a 7, so we have a 0, 1, 1, 1. That's 7 in binary. And then we have 8, so we have a 1, 0, 0, 0. Okay, that's B, C, D. Okay, and then we have a 6 over here, so we have 0, 4 plus 2, and a 0 here. Then we're going to go ahead and we're going to get 9. So that's 1 plus 0, 0, 1. And so this is 8 plus 1 is 9. So there we go. Now we add these together. Okay? So we're going to get a 1, a 0, 0, 0. Notice we got a carry this time. And this was off the bat. So that's an invalid. But we're going to add it anyway. So we're going to get 0, carry 1. We have 3 right here. So because it's odd, we're going to drop 1 and we're going to add 1. So we drop 1, we add 1. Again, it's odd, so we drop 1, we add 1. And then we should get something like that. So we should have 1, 1, 1, 0, 0, 0, 0, 1. Now, notice that there's 2 things. This is invalid because we carried the 1 here. Okay, so your book will use CY, invalid CY. And then this is invalid. And actually, I don't want to draw it like that because I want to have room to work. So I'm going to go from above. We'll look at this right here is invalid because it's greater. It's greater than 9. Okay. So in both these cases, what we can do is we can add 6. Okay. So if we do that, we get 1, 1, 1, 0. Then we get 0, 0, carry 1. This is 3 here, so we get a drop down of 1, carry 1, 0, carry 1. Okay, so this is 1, 2, 3, 4. So this one is actually outside of the range of the 8-bit binary, so we're actually going to have to include another binary set. Okay, and that actually makes sense if we think about it, because this is a 1, this is a 4, and this is a 7. And that is our decimal number. Okay, if we go ahead and look at this right here, this is BCD. Okay, that's in BCD. Okay. So that is all of the problems that I have for us for right now. We looked at an invalid carry. This is an invalid carry right here. And we also looked at greater than 9 invalidation. Okay, you can think about it too. If you have an 8 or a 7-segment display, okay, and you have to carry. So if you had a number that was beyond this digit to carry into this digit, it's going to be invalid. Okay, so you can only have 0 through 9. If you have 10 or anything above it, you're going to need another one of these things. So to adjust for that, what we do for the algorithm, which again it's teaching algorithms, is to add 6. So we added 6 right here on both of those. Okay. So the final, if you were doing 7-segment display, would have 3 of these, and it would look something like that. So that's how it would be created. Okay. All right.